Hey everybody, my name's Joseph Eley. I am a production engineer here at Meta, and I've been here for about 6 years. I work in the ads and business platform organization, and today I'm here in our Menlo Park office, and I'm going to talk to you about configuration safety and kind of the journey that we've had trying to take one of the most common causes of incidents, both within ads and at Meta overall, and making it more reliable. So, first of all, when we're talking about configuration safety, we need to understand what are configs and what are they used for. Well, they're basically a way to easily make changes to a service or program's behavior without actually modifying the underlying source code itself. Now, a common example that many people have probably interacted with at one point or another is something like the bashrc file, which there's an example of in the top right, where you can change the default behavior of a bash command without actually changing the source code of the bash command. And similarly, configs have been around for a very long time, longer than I have been alive. And the first example that I could find was the .ini file that was used to modify the behavior of MS-DOS on initialization. And that's an example of that is in the bottom right there. And they come in a lot of different forms. The .ini file is a key value kind of free form format, but a lot of times now they come in JSON, XML, and YAML files that are more machine readable and parsable. And they are used for a lot of different things. You can think of adjusting specific arguments to your service, maybe cache sizes or queue sizes, things like that, or pointing your program to send requests to a specific destination with like servers or tier names or job names. So now that we know a little bit about what configs are, I'll talk about how we do config development here at Meta. So here at Meta, we actually generate our config files. Rather than directly modifying the JSON fields, we have Python files that generate the JSON output. And you can see an example of a generator on the left here, where it's written in Python, so we have access to everything that Python has available. So all the built-in methods, we can have our own helper methods or helper classes that allow us to scale and make our code more versatile. But in the end, we export what's called a thrift structure, and we have a custom version of Apache thrift called FB thrift that's open source, and it just defines which fields we need to populate in the output. And so the basic process is you create or modify the generator file, you run a build process, and you generate the JSON output file. Then both the generator file and the output file are committed to the repository. And you go through a normal test and review process. You put up your code for review, someone approves it, and then you are able to land the change, and it goes to production, and then is consumed through the API that you can see on the bottom here. Now, the important thing here is that by default at Meta, when a config change lands, as soon as its landing is successful, within a few seconds, that gets propagated to all services. And it's a very powerful tool. It allows our developers to move and iterate very quickly or move on to the next part of their project or just see the effects of their change in production. However, with this type of great power comes great responsibility and, in our case, great reliability issues. So this is an example of one of the company's values and how it's changed over time. Values are kind of the cultural operating system, in a way, that guide us on how we do things here. The first version of this was move fast and break things. Now, it's kind of catchy, and it was kind of famous throughout the industry, but the idea was that we would move faster and tolerate a few more bugs. But over time, the amount of bugs actually started to hinder us, and prevented us from moving quickly. So around 8 years ago, it was changed to move fast with stable infra. And the idea here is that we would invest disproportionately into tooling and infrastructure. And then in 2022 here, it was moved to just move fast with the idea that we just want to remove all the barriers to help us accelerate the velocity of the company's highest priorities. And I actually really like this value that Meta has. When I first started here, I was straight out of college, and within a couple of days, I'd already made a config change to a test system. And then within a week and a half, I'd already made a change to a production system that affected that system. And configs is really one of the things that allows this move fast culture here at Meta. However, two of the most recent large incidents that we've had have been caused by config changes. The first one was early last year, where Instagram and WhatsApp went down for about an hour. And then very soon after, there was a change that Instagram, WhatsApp, and Facebook went down for a couple of hours. Both of these were caused by config changes. And just like this value and how it became more conservative over time, we have gone from a world where about 60% of config changes had virtually no testing at all to a world where we have a lot more safeguards put in place. So now I'll talk a little bit about how we use configs within ads. And so just so you can get a little bit of an idea about the scale of what we do here. We have about 10,000 of these generated config files that are consumed by over 100 critical services that are critical to the ads flow in one way or another. And we have 1,000 engineers that are trying to make commits on a daily basis. So we have, on average, about 400 manual commits that try to land every single day. And we need to have these land in a reliable way so that we can verify that we're not breaking our systems. One of the challenging things with that is that only 60% of the changes are actually from ads developers. Our systems are very complicated and use a lot of different libraries like routing libraries, caching libraries, logging libraries. And all of those libraries consume configs that are modified and owned by other parts of the company. And we have to make sure that those are tested just as well as our own ads configs. Now, some of these changes are just things that you would think of like normal service settings, cache sizes, queue sizes, turning on and off features, that kind of stuff. But in ads, we also have a lot of ML engineers that start and stop experiments or launch new models. And there's a lot of other different uses that we have for configs that I can't really go into currently, or don't have time to go into right now. But there is a blog associated with this talk that you can also read a little bit more in depth about that. So now that we know a little bit how we use configs, I want to talk about why reliability is important. And there's a few key stakeholders that ads reliability really affects, and one of the obvious ones is the advertisers themselves. The advertisers usually interact with their ad campaigns through something called Ads Manager. And say there's an advertiser that's trying to run a big Super Bowl ad or something, and they're trying to meet some sales goals. Well, if Ad Manager is not working properly, maybe they're not able to start or modify their ad campaign and they're not able to meet their sales goals. Well, that's a negative experience that we want to avoid, as well as maybe we launch a bad ML model or one of our services is down, so they just get less of a return on their ad spend. We want to provide as much value as possible for our advertisers for all the money that they're spending on our site. The next group of people that ad reliability affects is common users of our products like you and me. When you're browsing Facebook or Instagram, lots of people would say maybe it's just better if you don't serve ads. Maybe that's a better experience. But if we were in person, I would actually have anybody who's ever bought anything on Instagram or WhatsApp or Facebook through an ad to raise their hand. And myself included, I would raise my hand. I've bought something. And this actually adds a lot of value to the users of our products. And it's not necessarily just, is there not an ad or is there an ad? Sometimes if our products are down, maybe you just get a worse ad or like something you would not buy in a million years. Or maybe it's just really poorly targeted. Well, that's a negative experience that we want to avoid. And the last kind of stakeholder is Meta itself. We rely on revenue to continue to be a company and pay our employees and pay for our servers. So reliability is important for us as a company as well. So now that we understand why reliability is important, I'll talk a little bit about the journey that we've had for config safety. And the first stab that Meta had with trying to improve config reliability is this thing called directory-based selection. And so this was a mechanism that they put in place before I was even there that basically was a mapping between the folders that your service consumed configs from that you can see in the top left to a test spec that defined things like how long to run the test for, what tier to run the test on, how many hosts, and then you would define the metrics and the thresholds that would determine whether or not there was a regression. And this test would run at land time. So after you've already gone through the testing process, the review process, when you've hit the button to ship your code, before it landed, it would run this test. It would determine which test specs it needs to run. And if any of them failed, it would block your revision from landing. Now, this did a pretty good job and it served us pretty well for many years. But the issue with this is that, as you can see on the right here, this is an example of one service's folders that it consumes configs from. There's a service called AdFinder. So AdFinder, it's obvious that AdFinder would consume configs from the AdFinder folder, but it's less obvious that it would consume configs from the AdIndexer folder, which is a dependent service, or the caching folder, or the monitoring folder. And oftentimes we would start using a library that would consume some configs, but we would forget to add the folder or just not even know that this library was consuming configs from this folder. And so we would find ourselves in incidents because we wouldn't have the correct folders in our directory-based selection. And so what we did is we tried to find a solution that would allow us to have better coverage. Well, the library, the API that was on the previous slide, or one of the previous slides, actually logged like 1 in every 10,000 or so requests. Anytime you read a config, every once in a while it would log to a database and say, all right, this service read this folder or read this config. And we actually took that data set and we started dynamically building this list of directories. And from there, our coverage got much better, and we started to catch a lot of the issues that we were missing before. But there was still some issues with it. It was a solution that was specific to ads, and it was kind of hacky, and it broke all the time, and it wasn't officially supported. And so we started working with the Configurator team to actually make this into a first-class service. And it turned into something called consumption-based selection. And it's very similar to the directory-based one. And almost as soon as it existed, we had those couple of bad incidents that I was talking about a while ago that brought down a few of our large products. So almost as soon as it existed, it was now required for every critical service at Meta to now use this. And it's pretty simple how it works. Now the configurator client writes to a consumption database, and we have a 100% accurate list of every config that's consumed by every service, so we can accurately decide which tests to run when someone's trying to land their revisions. And it's very easy to enroll into it. You just specify the name of your service and use the same test spec that was on the previous slide. And you can now be pretty confident that you'll catch like a lot of the issues. Probably 99% of the bad commits that are trying to land will be prevented. But there was still some gaps that this solution had. And I'll go over what those gaps are in the next slide. But we ended up implementing this process called the gradual rollout process, where, like I was mentioning in one of the previous slides, by default at Meta, when you land a config change, it goes 100% to production. And that's a very dangerous thing. You don't usually deploy your normal service code from 0 to 100%. Usually you go from like 1% or a test region or a particular data center and gradually roll it out. Well, we took that mentality and applied it to configs as well. So we have this gradual rollout process where now we can decide how we want to roll it out rather than just going from 0 to 100%. And the gaps that this solved with the land time consumption-based canaries were that people were sometimes skipping those land time canaries. Maybe we had a noisy health check or something. Our thresholds were set incorrectly. Or people thought that it wasn't related to their change, and so they just skipped it, and we would find ourselves in an incident. Or sometimes we actually enforced that these were pretty short canaries, because like I said, there was 400 commits trying to land in any given time, or any given day. And if those tests were too long, people would have to deal with merge conflicts, and they could only test certain types of configs. Like if the config was only read at one time after the service starts, well, if you canary it for 15 minutes, it's not necessarily going to actually reflect that change in the test tier. So the gradual rollout process allowed us to solve and fill in some of these gaps, but it itself also had some issues where it only worked for ads configs. It's not very much a standard solution that's widely adopted throughout Meta. So it's pretty contained within ads right now, and we're having trouble adopting it for the rest of the company. And it's also comes with a lot of on-call pain, where anytime one of these releases gets blocked, our on-call gets paged and they have to try to unblock it. They have to revert the bad revision because it's already landed. And sometimes this causes delays for our developers, which is not something we want. So the next solution was that we had enough on-call pain and enough people were getting their changes delayed from going to production that we wanted to try to prevent the diffs from relying on these land time changes and the gradual rollout process as much as possible. It's meant to be a last-ditch effort to prevent these changes from landing. And usually when we're talking about code development, we want to catch the issues as early as possible in the life cycle. And so this is an example of one of my diffs from a few years ago. And it's a good example of what we would see a lot of times for test plans. Arc builds is basically how you tell the repository to build all of your changes and generate the output. So a lot of times it was just, does it generate the output? All right, we're good. And I would say about 70% of the time there was no more of a test plan than this. And so we tried to develop a way to enforce better test plans. We had an integration test framework that a lot of services use to test their actual service code. They were very in-depth A/B tests that the service owners would go and define the metrics for their service, and we actually used ML to decide the thresholds that would detect what the significant regression for each counter was. But we just weren't running them when we needed to. And so we actually took the same data set for the consumption-based land time canaries and started automatically launching or at least suggesting test plans for revision owners. And we would try to enforce this as much as possible. And our coverage went from like 20% to about 80% for some of our critical services within ads. And we saw a pretty big drop in the number of commits that were being caught by the land time canaries and the gradual rollout process, which was overall a very good thing. Our on-calls were having a better experience, and we were catching a lot more issues before they went to production because we weren't relying as heavily on the other two types of testing. And so now a full solution for config safety involves all of these different types of testing. And it's by no means a foolproof solution, but like each part has its pros and its cons. The land time canaries, they're easy to enable, they're standard throughout Meta, they're widely adopted, but they have some weak spots, like they have to be short tests, they're high level, they don't test certain types of configs, and they're skippable. Whereas the gradual rollout process, it fills in a lot of those gaps, but it also has issues with on-call pain, delays, and it's not widely adopted yet. The diff-time testing, like here, it's really good, and we should really rely on this the most, but it's still skippable, it's resource and time intensive, and so each of these has pros and cons. And we still have our work cut out for us to improve config safety. We still need to find a balance between the move fast culture and reliability. We need to find a way to have a controlled rollout of non-ads configs, or at least find a way to make it more widely adopted throughout Meta. And we still struggle with defining the health checks and the metrics that are significant for our service so we can detect the regressions in the gradual rollout process and the land time canaries. Thanks for listening, and I hope you enjoyed the talk.